I think we just once again. Yeah, that was already initiated. So all good. Yeah. I think now you're muted. Yes. No.
Okay,
Yes.
there we go. Okay, so starting by introducing our organizing committee, as Professor Wilma Martinez already introduced himself. I'm the general co-chair, I'm Hans Wouters. It's a good introduction to our technical chair, Wout van der Wegen, who just helped with the technical difficulties also. We are joined by Professor Chen from National Taiwan University as financial chair, Thomas Jochmans, Yang Li, Chait Sekon, and Yutso from our research group. As a starting point, I would like to invite you to contact us if there's any doubts or questions via the dedicated email address ifec26@kleuven.be. I'm always happy to answer your questions. And you can follow all the live updates on the dedicated website. So if you don't have it bookmarked yet, this is an invitation to do so. As we move along and questions are answered, we will also be updating the website as such. So IFEC 2026, coming all the way from Taiwan to Belgium, as we like to say, in the heart of Europe. It's very easy to visit and also to visit other places once you are in Belgium. Easy train connections all across Europe for just very short flights. It's also the capital of the European Union, as well as home to many local delicacies like the waffles, our famous beers, chocolates and fries, as well as some maybe well-known cartoon characters, some culture, and if your pockets are a bit deeper, even good diamond trade. Our research group is indeed led by Professor Martinez, so we invite you to check out the video here and get a more detailed introduction to our group. We are part of the Catholic University of Leuven. It's the oldest Catholic university in the world. It's we just celebrated our 600th birthday, so we got to blow out 600 candles. It's also home to many famous alumni like Georges Lemaitre, Mercator, and we have around 65,000 students at the moment, so maybe the next Einstein could be among them. We are also part of research institutes here, where we, as 4 kind of separate research institutes, collaborate under one umbrella called Energyville. It's where all the activities around energy transition are combined. This energy transition is quite explicit in our DNA because our site is also an old mining facility. So it's really the best place, let's say, to do research on renewable energy. In our research group, we mainly focus on 3 pillars. So just briefly mention, we work a lot on high frequency magnetics, wide bandgap semiconductors, and also artificial intelligence and design automation. So that's a little bit of background about us and where IFEC will be hosted. And we can move straight to the challenge itself. So as you might be already familiar with, the title of this year is Affordable Bidirectional Onboard Chargers for Electric Vehicles. So in general, we see nowadays in electric cars the status quo of what is the charging infrastructure of these onboard chargers. And we dare to dream that this will be drastically reduced in the future. And we invite you to be part of that development. So we also focus a lot on low costs, given that it's automotive, and also given the wider context. We also focus, of course, on traditional KPIs like efficiency and power density. The inputs is typical AC inputs, single phase, towards a 400-volt battery. And we limit the power to 1 kilowatts. And there are optional features like bidirectional integrated low voltage charger, but Wout will go deeper into those in a minute. Before we do that, we also see this as why we chose this topic. We'd like to share that with you. And first of all, we see it as a nice technical challenge. It's quite relevant also both for industry and for society. So that's the main motivation. If we look and situate this onboard charger in an electric vehicle, it's part of a bigger picture, of course. The onboard charger is the interface between an AC grid and the battery, and it's always on the board. So it's like having a charger inside your phone. So naturally, we want to make it as small as possible. And besides that, of course, there's the offboard charger who can interface directly to the battery if the voltages match, or we have the inverter as well. We can also do wireless charging. And besides, typically a car also has a low voltage battery that will power like auxiliary devices like the screens, the air conditioning, etc. About this, some of the technical challenges we see in research and industry right now. First of all, there's a size. As I mentioned, it's quite a large component. Many of them now, they can be as big as a crate of beer. It's a good analogy to think about. And so it's also good motivation to downsize it. Furthermore, the efficiency can be quite high at peak efficiencies, but we often see a drastic reduction at low power. And we can then think about powering your car with your solar panels at home. And yeah, much of the energy you are producing might be thrown away as heat. Besides, it not only depends on the power, but also the voltage and the state of charge of the battery. And this charging profile we acquired here experimentally, and we see quite a large dependency also on the voltage, not only on the power. Besides that, nowadays there's quite a lot of focus on bidirectional charging, where the car is not only a means of transport anymore, which that can increase its value a lot. So we see options like vehicle to grid, vehicle to home, to vehicle, and vehicle to load. And that's also something we will focus this challenge on. Nowadays, we already see many cars on the market offering this, mainly vehicle to load. So if you're on a camping trip, you can bring your PlayStation and still play it outside. Just as some context, we made a report on the state of the art of bidirectional onboard chargers 2 years ago. And we can see many details in this about power density and efficiencies that are achieved. But mainly I want to share this to inspire you to say, okay, let's check out some of these papers and really get some ideas about what's already done, because there's really interesting research behind each of these dots, I can say. So that being said, I would like to pass the word to my colleague Wout.
Yes, I can use the laptop. Okay, so let's start with the technical requirements. So we will begin with the minimum technical requirements. We have two sets. We have the ones that must be considered in your design, and the ones that are kind of optional, but still recommended to consider. So we'll start off with the AC inputs. So we have two set of input voltage, one of 120 volt AC at 60 hertz. There's a on the picture, 50 hertz, and at 230 volt AC at 50 hertz. Then the output is, of course, a battery. So we use a voltage range of typical 400 volt batteries found in cars between 300 and 450 volts DC. And there has to be galvanic isolation between the input and the battery. And we will test it with a high pop test. Then the maximum power is 1 kilowatt. And we want the peak efficiency of above 92%. Then cooling, we won't use water cooling, so only natural convection cooling or self-supplied forced air. Then we will provide an external 12 volt low voltage supply to supply your control electronics, and also possibility to supply your cooling fans. But the current is limited to 2.5 amps. Then open frame. So what this means is you can just, you don't need to design a casing. We will provide a box where you can test your converter in. So yeah, you have a safe operating space. Of course, if you want to design a casing, feel free to do it. It can have some nice, it can look nicer. And you're allowed also to reprogram your converter before doing tests. We will not use any batteries. We will use bidirectional power supplies. where we can emulate a battery. We have 3 different typical control modes, so constant current, constant power, and constant voltage. Then protection at the battery side. So we will use over-voltage protection that should be triggered between 450 or 455 volt DC. You can set this however you like. And also overcurrent protection, which should trigger above 4.5 amps. And the maximum response time is 100 milliseconds. And also your AC side should be fused properly. We put a specification of 230 volt AC. This is the maximum voltage at 15 amps of current rating. And the power density should be larger or equal than 2 kilowatt per liter, and should include cooling and EMI filters. And then, of course, with the affordability in mind, a cheap BOM is also recommended to look at. We will provide some kind of toolbox with fixed connectors, so we can, in the finals, we can test easily. So we have fixed connectors for the AC input, DC output, and for the 12 volt external supply. These are in the call for proposal, and you will have to use them. And then also for safety, and so you don't blow up your converters easily, a soft start or a pre-charge logic or circuitry needs to be implemented, so you don't blow up your converter when powering it on. And at the output ripple, at the battery side, that's open for the team to decide. And then we go to the more further specifications. So this is in the bidirectional operation. So you can use your battery to do a vehicle to load operation. So you can test if you can power your PlayStation. And it should be able to operate again at both voltages. So 120 volt AC and 230 volt AC in single phase. Then we will also check the efficiency at predefined charging profile, so the average efficiency, as you saw in the graph a couple of slides ago. We will still have to define this charge profile, but we already put some key points. So above 92% at 1 kilowatt, above 92% 500 watts, and above 80% at 100 watts. Then, of course, because we are doing an DC to AC with fixed sine wave, we want the THD below 5% at 1 kilowatt and a power factor of above 96% at 1 kilowatt. They will also do some EMC tests, only for conducted emissions, so not radiated emissions. And lastly, a nice addition is a low voltage DC charger to be able to charge your 12 or 48 volt auxiliary battery at 500 watts. To add to this, we won't include this LVDC charger in the power density mentioned before. Then there is also now on the site a frequently asked questions document. It's published and will be updated periodically. You can already check it out to see if some of your questions are already answered. And I'll give back, there are some notes still, forgot. So exceeding the proposal objectives will naturally increase in a higher score. So if you do better than what we ask, it's of course better. If a team only partially complies, we won't exclude you from the competition, but grade you accordingly. And also think about innovative solutions. It's make your proposal more attracting to us, and we will go farther into the competition. And next to that, if there are some design choices you have to make, for instance, this output triple, you can choose. Whatever, but make sure you can support your decision, so the jury will ask this supporting material and judge you accordingly. I give back word to Hans.
Yes, thank you. So maybe the most interesting part is next is the awards and the supports we can provide. First of all, as you know, there's a $10,000 grand prize for the team who scores the highest grades overall in the finals. Besides that, there's also additional prizes such as the Best Hardware Prototype Awards, Best Technical Report Awards, Best Presentation Awards, and these will be awarded according to the individual criteria of these categories, and there could be additional awards being announced soon. Besides that, there's travel support for the teams that come in person to the semifinals in the US and the finals in Belgium. Semifinals is optional to attend in person if there are issues with that, but the finals are mandatory. And the teams that do that, they will qualify for this travel support. Besides, we encourage all teams, as in other years, to be entrepreneurial. It's a student challenge, and it's also a good opportunity to, not only practice your hard skills, but also those soft skills. So you can contact either local or non-local businesses for financial support. IFEC will also support the teams by means of hardware and software. This will grow throughout different phases of the competition. At the moment, we can offer a simplest simulation license. You can visit the website available here and go through the steps. It's quite well explained, and get access to really good software simulation tools. There's also a lot of tutorials and documentation specifically for the student teams here for IFEC. So it's a really good set of tools. Besides, as Wout mentioned, we will be supplying the connectors toolbox, and this list will also grow as we go further into the hardware part of the developments. So stay tuned. Besides that, there's also collaboration this year with Empower a Billion Lives. So we, of course, welcome diverse teams from across the world. And if additional support is needed for your case, please just reach out to us, and we are always happy to discuss different options. Voila, going to the program. As also shared on the website, this is the current program. Today we're having the kickoff workshop. We have the proposal deadline for middle of November. 1 month later, there will be the notification. We will have on March 22nd a workshop at APEC where teams can present their current status. Finalists will be announced and be invited to come to Belgium in summer. Besides that, we're discussing opportunities for online workshops and tutorials. So these will also be announced to the participating teams. Some of the rules, the general rules that we would like to re-emphasize is that each of the teams should consist of mainly, let's say, students. So it's quite important. It's a student competition. It's not a PhD graduate student competition. So it should be a team of students doing the work basically, and there can be supervision by grad students. Proposals should contain a letter of support, also team information and the actual proposal. I'll come back to that later. There's some requirements for the layouts that you have to follow. And the requested criteria in the design should, of course, be discussed for us to be able to judge your proposal. Deadline is November 15th. So it's 15th of November at midnight, let's say Brussels time. And it should be shared in a PDF document to the according email address. All proposals will then be reviewed and be modified. And also, just an important side note is to follow the code of conduct for the use of AI. There's some details in the call for proposals. So it's not excluded. You're allowed to use AI, but in general, just use it in an ethical way. So, as said, if you haven't seen it already, I invite you to check the call for proposal. It includes all the details in more depth than what we covered today. It's published on the website you can visit, and there's also a direct download link available. We just recently also, as an answer to some of your requests, published a template for the proposal, which has some fields to fill in that meet all the requirements. It has the layout as defined, and also kind of a structure, possible structure. In general, we invite you to think about the proposal and to really consider that a good proposal for us demonstrates mainly a team's technical understanding of the challenge and kind of show your strategy for how you want to achieve these objectives. Besides all the technical parts, IFEC is also really a social event. So there will be technical events organized as mentioned. These are really for students a nice opportunity to show your work to industry leading experts. It's a quite unique opportunity. You can share but also grow your expertise and attend these workshops and panel discussions. And we've from participating in this event, we've seen students really grow throughout the process. Besides, there's also a lot of networking opportunities. You can get in contact with industry-leading companies and academic institutes, share experiences with students from across the world, and generally just get inspired by a lot of creative minds. And of course, as I mentioned, there's a lot of Belgian delicacies that we will like to invite you to try, and much more. So we are also organizing some events during the finals, like these offshore wind facilities that are here in Belgium, to visit this. Finally, we invite you to follow us on LinkedIn, our Power Electronics Research Group. We will also be sharing a lot of updates there about the IFEC challenge and in a more broad sense. And with that, I conclude my presentation. So thank you very much for your wide attendance. Let's inspire and get inspired from each other. And if there are questions, we are very happy to discuss them. So if someone has a question and you're happy to open the mic, I see Vincius Bessa raising your hands. Please, if you're willing to.
Good morning.
Yes, we
Good
can hear
morning.
you.
Are you hearing me?
Yes. Morning.
I have a question about how would travel support work? Will it be in the form of a refund or something?
Yes, so how it has been last year, you will fill in a document, you will bring in your receipts, and after a waiting period, you will receive the money back.
Okay.
Yes,
Thank you very much.
This is a constraint we have, but typically we try to process it as soon as possible, but it's a reimbursement indeed. Thanks for the question. I don't know if there are questions in the chat.
I have another question. Is there a reward for not using the power supply available on our site, the 12 voltage?
Well, in general, as just in a fair judging way, it's not a requirement to not use it. Of course, if you don't, it's a technical bonus, and all technical bonuses are awarded accordingly. So yes, it will be an award. We cannot say, okay, you get this many extra points, but it will be taken in consideration in the jury.
Okay, thank you.
I think Simon had a question regarding if you can use heat sinks. Yes, you can use heat sinks. I think this is the answer to your question. And then protective earth. Yes, we should add a connection for protective earth. We'll update this in the call for proposals.
Okay. Then I see a hand raised by Muhammad, I believe. Muhammad Abdullah, can you open the mic?
I'd like to ask a question.
Yes, Muhammad, we can hear you now. Go ahead.
In your introductory video on the IFEC webpage, you say the teams from developing countries would be provided with fundings for components. What would be the procedure for that, and how much amount we should allocate for that in our financial panel?
Yes, for that, please just reach out to us via email and we will do it on a case-by-case manner. So please just send us an email and we can look at it together.
Okay, thank you so much.
Yep. Thanks for the question.
This one should also go to email.
Okay, so sorry, let's just see. So there is a question about eligibility requirements in the chat by Alberg. Please, Alberg, if you can, please just send us an email. We will be happy to look at the case, look at the details, and see what we can do to make it happen together. Yeah. Then, hello, Bryce. Please.
Hi.
Yeah. Hello.
So you mentioned powering a PlayStation as an example. So I presume this means that you can do islanding. In other words, it'll put out the sine wave without being connected to a grid. Is that right? Or are we
Yes,
supposed
indeed.
to be...
So yeah, in the vehicle to load case we are considering, there's no actual grid connection, so it's for powering loads directly. Indeed.
Now,
does that answer your question?
Yeah. Is there some like digital input that says, now we're going to do a load, now we're going to pull power from the grid? How is that controlled?
So we only consider in the from battery to AC power flow, we only consider a load. And if we go in the other direction, you can reprogram your microcontroller. So there's no digital input needed.
Yeah, it's not a requirement, but of course teams are free to interpret this and implement it in their own way. So if you want to have a nice interface for that, this of course again will be awarded accordingly, but in general the rules only state that it needs to be able to operate in both ways and it can be reprogrammed between these runs.
Okay, I get it.
Yeah.
Thanks.
And then, yeah, Simon, so the connectors, they should be on the PCB, but they are excluded from the power density. Yeah, I don't think it's beneficial to use flexible wire connections.
Yeah, you can like many prototypes you see will have kind of the main converter stage, and in this case the same. You can have like a brim basically around your converter on the PCB itself that will have the connectors, and then only the connectors, and that brim will not be included in the power density. So that's a possibility that we leave open for the teams. Okay, I see Ines raising your hand. Please go ahead.
Hello, yes. Can you hear me?
Yes.
So I had a quick question about semifinals when we would actually be constructing the design. My question was whether we would have to conduct or create everything on the spot during the design competition, or would we be allowed to come with boards or other parts that were already created?
Yep. Yeah, good question. It's a good opportunity to clarify this. So in general, the competition will have the student teams developing and building everything at their home institute, let's say. There will be some hardware provided by IFEC, as mentioned. But then you can go ahead, build it in your lab. You can test it, characterize it, reiterate your design as needed, bring the hardware. Optionally to the semifinals, there's always some teams that can bring their hardware prototypes, but at that point, typically we expect a nice presentation and you show kind of your progress and your work plan going further. In the finals, you have to bring the hardware prototype, and we will connect it here to our setup, and we will test it. Is that clear?
Yeah, that's clear. Thank you.
Right, cool.
This, yes.
Sorry.
Islanding is required. Yes, there will be. It will not be connected to the grid. It will be connected to a load converter. If that answers your question, Paul Gerard.
Okay. We assume that can be clear. Okay, Mr. Bessa, you can open the mic again.
Well, I want to make it clear. Is it the semifinals in person, and we have to go, or there is no need to?
So semifinals will be hosted out of San Antonio in IFEC, but it will be hybrid. So if it's difficult to attend, you can just attend online. Of course, for students, it's nice if even part of the group can attend. But of course, we understand that this is difficult, and you can also join online for the semifinals.
Okay.
Yep.
Okay, I have another question. It's about how many members there we have to take to the Belgium in the finals. There is a minimum team members, or can, let's say, 1 or 2 go?
1 or 2 is fine. There's no minimum number of members that have to come.
There is only one.
There is no need for.
There is one limitation, and that's the member who presents should be an undergrad student.
Okay, and then there is no need for a professor to follow us.
I would have to check the formal regulations, but from our sides, we don't see that need now.
Okay, thank you.
No.
Think.
Okay, so you see a chat question on behalf of the team H Bridges from Serbia, wondering whether the charging profile will impose any constraints on the response time or control loop bandwidth. Yeah, Wout, you can.
No, I think I also answered it in the frequently asked questions, but I answered it also. I saw your mail. I will put it also my answer on mail to you. General, no.
Okay. So another question in the chat by Sidnik, I believe. Does a low voltage DC 500 watt charger has to supply both the 12 volt and 48 volt, or only one of them? To cover your first question, no, only one of them. So you can choose a low voltage battery voltage, let's say nominal voltage. It's just that we see traditionally 12 volt batteries, but nowadays also more and more 48 volt batteries, such as in the Tesla Cybertruck. So in that sense, we open it to you if you want to implement a low voltage DC output to choose the voltage. And secondly, how do we set up the output voltage in range from 300 to 450 without digital inputs and any interface?
So you have first your constant current charging, then you only look at the current, and you have constant voltage charging, then you set an output voltage and you look at the voltage. You can implement a way that it shifts between them, but I would first focus on them separately.
Okay, so Sidney, hoping that answers your. All right, you're very welcome. Paul Geracht, we already covered that one, so I guess we are up to date on the questions on the chat. So if anyone has any burning questions, feel free to ask them. This is a good time. Another from Paul Geracht. Do we have to regulate the output current in charging modes down to 0 amps, or can we cut off earlier? At which current or power? we have to regulate low current charging at low battery voltage?
You can. We will put a requirement. That's a good point. We will put a requirement that you can cut off earlier. And at low current charging at low battery voltage, it's typically not done. So I would, to stay realistic, will not consider this.
Yeah, but again, we will provide still a more detailed charging profile with all the conditions to consider later along. But it's a good point that we will indeed take into consideration when constructing or finalizing that profile. Okay. There's a hand raised by Ines. Please feel free to open the mic.
Yeah, sorry, I'm just a tiny bit lost. You guys were mentioning 12 and 48 volts. Is that when it's going from the battery to, let's say, some output, like you were mentioning, an Xbox controller? Or is that an internal power supply? Or what exactly is that 12/48 volts?
Also a good question. We intended to also, again, leave it quite open. Nowadays in powertrains, we also see different options, either having the low voltage being charged from AC or from the battery. So again, we also leave this open to you. So you can choose to power it from the battery or from the AC to a separate output.
So to make it clear, we will provide a 12-volt supply to supply your control logic and cooling. And then you can implement the low voltage DC charger to charge a 12-volt battery or a 48-volt battery. How you do this, if you use the AC to DC side or DC to DC to charge, it's up to you. If that answers your question.
Okay, that makes sense. And that would be alongside the obviously bidirectional charging.
Exactly. Yeah.
Okay.
Yeah. Going back to the powertrain is there's the fact that now we have a high voltage battery, but still we typically have a separate battery for all the auxiliary power that needs to be delivered. And so often we see even in industry kind of a combined charger that merges these two devices. So the low voltage DC-DC, or it can also come from AC. In our case, we are open to be flexible on that. But yeah, thanks for the question. So Paul Geracht, should the proposal include a BOM with exact part numbers and prices, or is it more like listing the number of switches, capacitors, inductors? So yeah, we don't expect a full detailed bill of materials at the proposal level, but in the final design, of course, we expect a detailed BOM. But at the proposal level, it can be a preliminary bill of materials, including what you already kind of decided on, depending on the rest of the proposal. And then based on that, you already can also use this as an argument for how you considered affordability in the design. So of course, if we see a bill of materials using a lot of custom components and expensive parts, okay, we can take this into the consideration, but it all depends on your explanation around it. And this could be preliminary and your future plan could tackle this. Yeah, that's kind of the viewpoint on that. Okay, I'm giving a last opportunity to ask a question. If there's another question, please raise your hand or shoot a message now. Bryce, okay, please go ahead.
Hey, so I think you said that there wouldn't actually be a grid connection. So I'm presuming it's a power supply that we're connecting to that puts out AC. And then, but for pushing it back to the load, or how would I put it? So if we're connected to, say, a bidirectional power supply that can supply power, but it can also accept power, would we be putting power back into that or into some passive load that can't put out any power? I'm just trying to understand the bidirectional part of it.
Yeah, good question. Wout, I don't know if we already decided on the testing setup.
So you mean on the AC side power supply, right?
Mm-hmm.
For the AC side power supply, we don't have a fixed. We don't decide it yet. To either use bidirectional like AC loads, like a digital AC load, or just a resistor. Let's say. It's not decided yet. Of course, we would like AC loads since it's easier, more safe. But we have to see with which material we can get here in-house.
Yeah, so we will flag that as an open point for the moment, Bryce. I mean, at the moment, we're kind of in the middle of the fixing and finalizing the test capabilities for the finals, also considering the amount of teams that will come. And then based on that, we can log the answer in, and then we'll be happy to come back to you once it is decided, if that's okay.
Okay.
Maybe if I can add on that, so indeed we distinguish two modes. So the charging mode will come, of course, from the power supply. Will charge and will go through the converter through something. And another thing is indeed that is charging mode, where of course we will use another power supply and then a load. But indeed, as Wout mentioned. More clarification will be given in the documents.
Okay, so assuming there are no more questions, I think we can finalize the workshop and the info session. So again, thank you all very much for attending. It was quite an informative session. If there are more questions you didn't get to ask, please feel free to email us again. And we look forward to reading your proposals by November 15th. So good luck to everyone and hope to see you soon. Thank you.
Thank you.